Hello and welcome to Chegg's Live Office Hours. This is the Stoichiometry Live Office Hours section. We have live office hours all week. If you look at the QR code in the top left, you can find all of the hours we offer for different classes like chemistry, calculus, everything you can think of is there. And we are so glad to have you. Chegg has been so nice as to provide these live office hours for us so that we can learn more about the classes we're taking and get help with anything we need help with in regards to those classes. I'm Allison. I am going to be your leader of this session. I have TA experience in chemistry and organic chemistry. I've also been a personal tutor for that, a student learning assistant for chemistry, and then I've also been a tutor for calculus. So I have a little bit of experience in teaching chemistry. We're going to be focusing on the math part of chemistry, stoichiometry. So throughout this live stream, if you have any questions, I encourage you to type those answers and questions in the chat, whether you're coming from Twitch or TikTok, whatever you're coming from. Type those questions. I'd be more than happy to answer them. That's what I'm here for. And I'm also going to encourage you throughout this live stream to answer the questions that I ask and try to solve the problem before me so that helps you better learn and better understand. So that's what I'm going to encourage you to do. And yeah, we're going to get started with some questions that I created. We'll start with a little warm up and then we will answer any questions you guys have. So our first question we're going to start with tonight is what is 32 millimeters per second to kilometers per hour? So when I'm solving stoichiometry problems, if you're new, I would use what we call the factor label method. And it's a really neat and easy way to organize your thoughts in math chemistry. And so if you haven't really developed your own style of solving these problems, this is the way I would encourage you to do it. And for this first problem, I'll really work through why this works and why I encourage it. But we start with 32 millimeters per second. In these problems, you always start with what you're given. So I'm given 32 millimeters per second. That is what I'm going to start with. And then I need to somehow end with this kilometers per hour because that's what the question is asking. So this is a little bit difficult. I do know that most of y'all are probably pretty far off into chemistry, so that's why I kind of chose a more difficult warm-up problem. But for this, we're not only going to need to change the top units, we're also going to need to change the bottom units. So I always start with the top, but you can start with the top or the bottom. And basically, for this factor label method, whatever's on top, we need to put on bottom to cancel it out. And then we want whatever unit is in the end to be on the top or bottom that corresponds to this ending unit. So we want kilometers on the top in our final answer and hours on the bottom in our final answer. So what I'm going to do is I'm going to go millimeters to meters because I know that conversion. I'm assuming that most of your teachers are going to have you memorize how to get from meters to millimeters, meters to kilometers. I know all of my teachers did, so I'm going to assume that we have that memorized or that we're in the process of memorizing it. So I always like to go to meters or our base unit. That base unit can be meters, grams, liters. I always like to go to that base unit first before transferring to my other unit. And then I'm going to go from meters to kilometers. So the reason that I do this is now I can cross out my millimeters and I can cross out my meters and I'm left with kilometers and my kilometers corresponds to what's on the top. So I know that I at least have that top unit correct. And I go in and fill out all of like the conversions at the end. That's how my mind works. But if you want it a different way, definitely type that in the chat and we can put the conversions in as we work. Now, I'm going to focus on getting this bottom seconds to hours. So I have seconds on the bottom. I want to cancel it out, so I have to put it on the opposite of whatever it is. So I have to put seconds on the top. And then I don't know the conversion from seconds to hours, but I know the conversion from seconds to minutes and minutes to hours. And then we can kind of see my minutes cancel out and my seconds cancel out. And I'm going to be left with, in the end, kilometers over hours, which is what the problem wants. So we are doing great. Now, I'm going to give y'all a few seconds to type what any of these conversions are. Let's see how much you've memorized, how much you know. If you know any of these conversions that I haven't yet filled in the next 10 seconds, I want you to type what those conversion numbers are. All right, 3, 2, 1. Okay, if you said for meters to millimeters, if you said the meters had a 1 and the millimeters had a 1,000, you are absolutely correct. There's 1,000 millimeters in 1 meter. For kilometers to meters, if you said 1 kilometer has 1,000 meters, you're absolutely correct. Great job. Then 1 minute has 60 seconds. This is a pretty easy one for us. And then 1 hour has 60 minutes. So if you got those, you're on a great start and a great track to learn hopefully a lot throughout this live stream. And now the reason that I like this is because now we just multiply the top and divide the bottom. So into my calculator, I'm going to put 32 times 60 over 1,000 times 1,000. And I'm going to give us about 30 seconds to put that in our calculator. And I would like you guys to type what that answer is into the chat. So you've got 30 seconds, put it in your calculator, solve, see if you can beat me to solving it, okay? Got about 20 more seconds. About 10 more seconds. 5, 4, 3, 2, 1. All right, if you guys said 0.1152 kilometers per hour, you are absolutely correct. Great job. There's one little tiny thing we need to do before we can say this project, or not this project, this problem. Goodness, it's a Wednesday night for sure. This problem is done is that we need to use significant figures. I haven't gone over significant figures in a few live streams, so we're going to kind of go over it closely just so we can refresh. I know y'all are probably getting ready to take midterms, so it's always good to refresh before midterms. So, sig figs, basically however many digits that are not zero that we start with, we have to end with. So we start with 1, 2 non-zero digits, so we have to round this answer to 2 digits. So if we round that, that's basically going to get 0.12 kilometers per hour. So if you got either of these answers, but if you got the 0.12 kilometers per hour, you're correct. So great job, guys. As a reminder, if you're just now joining in, it is so great to have you. Thank you for joining Cheg's Stoichiometry Live Office Hours. I'm Allison. I'm your host for this session. We have live office hours all week, so I encourage you to join whichever office hours apply to the classes you're taking. It's going to be a great learning experience for you. And throughout this live stream, I would love for you to ask any questions that you have. That's what I'm here for, is to answer your questions. And I would love to help you with whatever you need to know about stoichiometry. Now, for our second warm-up question, what is the molar mass of KC2H17O11? If you know this conversion, if you know what this name is off the top of your head, I'm going to be super impressed because I have no idea what the name of that compound is, but we're going to figure out its molar mass. So the way that I like to do this is I separate my compound into its individual elements. So I know I have 1 K, 2 C's, 17 H's, and 11 O's. Now, I'm going to encourage you to try to solve this problem quicker than me. It's going to take me about probably 5 minutes. So see if you can beat me in solving this. I'm going to be so impressed and so proud of you guys. All right. So we have K. What we need to do is find that molar mass of K. So if anyone knows the molar mass of K, if they can find it on the periodic table, let me know. If you got 39.10, you're absolutely correct. So we have 1 atom of K times, or 1 mole of K times 39.1 grams per mole to get our grams. We have 2 moles of C times 12.01 grams per mole to get our grams of carbon. We have 17 moles of H times 1.01 grams per mole to get our grams of H. And then we have 11 times 16 grams per mole to get our grams of O. So if you know how to solve this from here, again, I encourage you, beat me to solving it. But now we're going to put these all in our calculator. So 1 times 39.1 is 39.10 grams. 2 times 12.01 is 24.02 grams. 17 times 1.01 is 17.17 grams. And 11 times 16, I'm going to need to put that on my calculator. I don't know that one off the top of my head. That is 176 grams. Pausing real quick before we finish the problem. If you're wondering where I got these numbers from right here, that's from the periodic table. You're going to see it might have the labels AMU, which stands for atomic mass unit. Atomic mass unit and molar mass of an individual mole of an element is the same. I don't know why there's different names for it, but I found these numbers from the periodic table, and your teacher will give you a periodic table on tests. I've never met one that doesn't, so that's where you find that information. Our final step of finding the molar mass of this compound is to just add all of these together. All of those numbers that we just multiplied, we want to add them together. So I'm going to give y'all about 45 seconds. Put that in your calculator. Let me know what you get. See if you can beat me to solving it. All right, about 30 more seconds. All right, let's see those answers. 10, 9, 8, 3, 2, 1. If you got 256.29 grams per mole of compound, you're absolutely correct. Great job, guys. I hope we are learning lots. And the reason that we don't have any significant figures for this is what's in the periodic table is already significant figures. So that is how we don't have to use sig figs. And from the office on YouTube, do you guys do stats? We have a QR code in the top left with all of the different topics we use. So I encourage you to check that out. All right, now I want us to do a new skill tonight, and that is finding K equations. We've done this a lot throughout the past weeks, or we've talked about it and kind of touched up on the subject, but I want to get this skill nailed down, and I want you guys to all feel really confident in finding K equations after this. If you're just now joining the live stream, it is so great to have you. Ask any questions that you have. That's what I'm here for, and I encourage you to join other live office hours this week. So we want to set up the equation for K. We have this equation, N2 plus O2 yields into O. And just as a little brief kind of recap of what a K equation is, K is a rate constant. It's really important in solving rate problems and rate of reaction problems, which most schools I don't think touch till chemistry 2, but it is very important. And I know a lot of people take Chem 2 in the spring semester. So K is our rate constant. And how we measure K is we have the concentration of products over the concentration of reactants. And in these K equations, we only use gas and I think it's aqueous, I believe. So we only use those. Anything that's solid or liquid doesn't make it into our K equations. But the first step to balancing any of these, or to solving any of these, is balancing. I gave it away. So let's balance this equation. I'm going to give y'all about 20 seconds to balance it, and I then will start solving, but see if you can beat me in balancing this equation. You've got 20 seconds starting now. All right, 5, 4, 3, 2, 1. Okay, so the way I would always start is I'll pick one thing to balance on both sides. I'm going to pick into. I have two ends on this side, two ends on this side. So I don't need to do anything with that into for right now. Then I have two O's on this side, but I only have one O on the right. So to make that balance, I have to put a 2 in front of my N2O to have the same number of O's on the left and the right side of my equation. But now I have 4 N's on the right and only 2 on the left, so I'm just going to put a 2 coefficient in front of my N2. And then I'm just going to do a quick little check to make sure everything on the left is equal to everything on the right, and that indicates that my equation is balanced. So I have 4 N's over here, 4 N's over there. I get that by multiplying the 2 times the 2, 2 times the 2, and then I have 2 O's over here and 2 O's over there. So my equation is balanced. It's a pretty easy equation to balance. Now I want to set up my K equation. So what we just kind of talked about is K equals concentration of products over concentration of reactants. So I'm going to put K equals N2O over N2 and O2. So N2O over N2 times O2. All of these are aqueous, so all of them are included in my K equation. Now, one more little thing that I didn't touch on is if we have a coefficient in front of a compound, it becomes an exponent in our K equation. So wherever these 2's are, they're going to become a 2 exponent. So N2O has a 2 in front of it, so it has an exponent of 2. N2 has a 2 in front of it, so it has an exponent of 2. O2 only has like an imaginary 1, so you can write that 1 if you want, but anything to the first power is just itself, so we can kind of forget about that 1. But this would be the K equation for that chemical equation. If that's making sense, send a thumbs up or send a I get it. And if it's not making sense, type any questions that you have so that I can answer them. I can go into more detail regarding this. I can explain why we have to do this. So if you have any of those questions, feel free to type them in the chat, or any questions in general, whether that be about homework or something you went over in class. Type those questions in the chat and I would be more than happy to answer them for you. All right, next we want to set up the equation for K, and this is gold plus NaCN. Okay, so I see we're getting some thumbs up. We're kind of understanding. Perfect. So gold plus sodium cyanide yields gold cyanide plus sodium. So what we want to do first to solve for K is, again, balance that equation. I think this is going to be pretty easy to balance, actually. I might have made this one too easy. We have AU on the left and AU on the right. So one of each, that's fine. We don't need to touch it. We have 1 Na on the left, 1 Na on the right. 1-to-1 ratio again, don't need to touch it. 1 cyanide, 1 cyanide. We are good. We don't have anything to balance. So let's set up that K equation. I'm going to give y'all about 30 seconds. Type in the chat how you would set this equation up if you saw this on a test. I'm going to give y'all a little hint. I tried to trick you. So see if you can figure out how I'm trying to trick you. You'll get a virtual high five if you figure out how I'm trying to trick you. You've got about 20 more seconds. And if you don't want to type out the whole K equation, you can just let me know how I'm trying to trick you. All right, about 10 more seconds, guys. What's the trick here? All right, 5, 4, 3, 2, 1. All right, so when I am tutoring, I'll see a lot of kids who are going to do this right here. They're going to put, okay, I've got AUCN on the top. I've got NA on the top. All right, I've got AU on the bottom and NaCN on the bottom. I've even done this on a test and I regretted it a lot. This is wrong. The reason this is wrong is AU is not included in our K equation because it's solid. Because that phase is not aqueous, it's not gas, it is not included. So rewriting that, what we should have written is K equals AUCN times Na plus over NaCN, and that is our K equation. Thumbs up if I didn't trick you. Thumbs down if I did trick you. And if you have any questions, type those in the chat and I would be more than happy to answer them. If you're just now joining this live stream, welcome to Cheg's Live Office Hours. This is the stoichiometry version. I'm Allison, I'm your host, and I would love to answer any questions you have. Type those in the chat wherever you're streaming from, and I would love to help you with whatever you need chemistry and stoichiometry wise. And if you have a question about another topic or subject, check that QR code out in the top left to figure out what other courses we offer live office hours for. All right, now we want to find the value of K for this problem above if each of the initial concentrations is 2 molars. So any ideas on how we would solve this? This would be a little tougher if we had some exponents, but basically, if all of the concentrations are 2 molars, we're just going to plug 2 in for every bracket. So we would have K equals 2 times 2 over 2, which if we solve that, we get 4 over 2, which is just 2. So K would equal 2. My arrows are not doing good today. Oops. So K would equal 2. Hopefully that makes sense. I think we'll maybe work on that a little more in this next problem, which is a rate of reaction problem. So I know we were struggling a little bit last week with rate of reactions. So this one is going to be a little bit more in depth. And I also chose numbers that weren't like to the 28th power so that we didn't have to do really complicated math on the screen. But we want to know what's the concentration of N2 at equilibrium. If I start with 4 molars of N2 and 2 molars of O2, K is equal to 20. So I kind of cheated a little bit because we just solved this, or we didn't solve it, but we balanced the chemical equation. So we're just going to copy those numbers because I feel pretty confident that we all know how to balance equations now. So we have a 2 in front of the N2 and a 2 in front of our N2O. So I'm just going to go ahead and add those in. And now we want to create our ice table. I'm going to do a quick little run through of what an ice table is because I know this is some of our first time joining a live stream. And then some of us may not have seen rate of reactions yet, or it may have been just introduced today. This is what an ice table is. So in chemistry, we have rates of reaction. We have these chemical reactions where our reactants become our products, and how fast they become those products is what our rate of reaction is. And then we reach this point called equilibrium. Equilibrium is when the chemical reaction is at peace, kind of, and nothing is really, we're not shifting if we have more products or more reactants. It doesn't mean that the reaction has just stopped occurring. It just means we're creating products and reactants at an equal rate. That's a trick question teachers will ask you on tests. They'll be like, hey, does equilibrium mean the reaction stopped? Answer is no. Reaction means that reactants and products are being created at an equal rate. So that's your little chemistry tip for the day. But basically, we make these ice tables to solve rate of reaction questions. It's a really easy way to kind of visualize what's going on in those reactions. I stands for initial, C stands for change, and E stands for equilibrium. So I just kind of touched on what that equilibrium means. Change is like, how fast are we going from reactants to products? Are reactants appearing? Are products appearing? That is what that means. And initial is what we start with. So I'm going to kind of erase these words so that we can get started on that problem. And let's see what we start with. So this says we start with 4 molars of N2. So I'm going to put a 4, and I'm going to put it in brackets so we know it's molars. And it says we start with 2 of O2. And then we're not given any information on N2O. Most chemical reactions, we don't start with any product. So we can just assume that this number is 0. And I'm sure that some of your chemistry teachers will do the same. So always, if you're not given a concentration of product, assume that product concentration is 0. And you can logically think of that as we don't start with a product in a chemical reaction. When you're trying to create a compound, you don't start with that compound if you've had a chemistry lab. Then we're going to do change. Change is how fast is this reactant disappearing? How fast is this product appearing? Now, we always say reactants disappear unless the problem tells you otherwise, because if you think about it, reactants have to make the product. If you start with no product, the reactants have to disappear to create that product. So we use a minus sign to show disappearing. For this O2, it's just going to be minus X. Now, if that element, if that compound has a coefficient in front of it, it gets a little bit trickier. We have to bring that coefficient down. And so this N2 is going to be minus 2X. Now, if it's minus 2X because the reactant is disappearing at a rate of 2x, and it's minus x because the reactant is disappearing at the x. And we know the product is being created. What would we put as that change for that N2O, that dinitrogen monoxide? What would that change be? I'm going to give y'all about 15 seconds. Let's see if you all are familiar with this, and let me know what you would put if you saw this problem on a test. All right, about 5 more seconds, guys. What should we put for our change for dinitrogen monoxide? All right, 3, 2, 1. If you said plus 2x, great job. You all are doing so good. And that is what we would put is plus 2x. Now, to get that equilibrium value, what we're going to do is we're actually just going to bring kind of everything down. I'll kind of draw some arrows to demonstrate. This E for the N2 is going to be 4 minus 2x. E for the O2 is going to be 2 minus x. And then N2O is just going to be 2x because 0 plus 2x, 0 plus means really nothing. And then, like we practiced earlier, we have to put that into our K equation. We're going to assume that all of these are aqueous. I forgot to write that out, but we're going to assume all of these are aqueous, and let's put them into a K equation. So we have K equals products over reactants. All right. This is your time. Where did I mess up? You've got 20 seconds to tell me where I messed up, because I've seen a lot of the students that I tutor in chemistry do exactly this. This answer is incorrect. You have 15 seconds to tell me why it's not correct. Part of stoichiometry is figuring out why things aren't correct and making sure you don't make those mistakes, because little mistakes like this will cause you to get a whole problem wrong on a chemistry test as much as it sucks. All right, you got about 5 more seconds. What did I do wrong? 3, 2, 1. All right, if you said I forgot the exponents, you're absolutely correct. I have to put my 2 in my exponents. That way, I can make sure I'm accounting for that rate of reaction change and getting that K value correct. So now we know that K equals 20, so we can set 20 equal to this whole thing. Yes, good job, Estefan. From YouTube, K equals 20 is absolutely correct. All right, now, I know it's always helpful to go through the math, so this is our big math problem for the night. We are going to solve this using the quadratic formula, and it's because some teachers are going to require you to solve this by hand. I wasn't allowed a graphing calculator. I wasn't allowed any calculator, actually, on these chem tests. So we are going to figure out how to use the quadratic formula for this. So first step, I want to simplify everything as much as I can. So I have 20 equals, I'm going to square this 2x. One other thing that students normally really mess up on is squaring 2x. You have to square the 2 and the x. As a math tutor, I've seen this a lot. 2x to the second power becomes 4x squared. So make sure you're squaring that 2 as well. It's a really easy way to miss points. And then we can keep that 2 minus x the same. Now let's square our 4 minus 2x. I always like it to write it out somewhere. That way I know I'm not missing anything, and then we can FOIL. So first, we have 16 times outside. That would be negative 8x. Inside is another negative 8x. Last, negative 2x times negative 2x is plus 4x squared. If I'm going too fast at any time, if you want me to slow down on the math, type that in the chat and I will go through it better. Like if the FOIL thing's confusing you, let me know. I'll slow down on that. All right, and now what we need to do, let's keep simplifying. We have 20 equals 4x squared. I can now make this 2 minus x, and I can make this 16 minus 16x plus 4x squared. And then I'm going to simplify one more time before I try to start solving for x. I'm going to kind of FOIL, except it's not really FOIL because I have 3 in my right, but I'm going to multiply everything on the bottom. So 2 times 16, 32. 2 times negative 16x, negative 32x. 2 times 4x squared, plus 8x squared. Negative x times 16 is negative 16x. Negative x times negative 16x is plus 16x squared. Negative x times 4x squared is negative 4x cubed. Oh, this might not be the quadratic formula. I did not think this through very well. Oh, well, we're still going to try to solve it. Okay. Now, what we're going to do is multiply everything on the bottom over to the left side. So in our calculators, let's put 20 times 32, because I don't know that off the top of my head. We have 640 minus 640x plus 160x squared. And then minus 320x plus 320x squared minus 80x cubed equals 4x squared. Then I'm going to kind of simplify that left side again. So I can combine negative 640x and negative 320x, and I'm going to get negative 960x. I can combine 160x squared and 320x squared to get plus 480x squared. And then I can combine, let's see, what else can I combine? That's really it for now. Minus 80x cubed. I'm just going to write everything and bring it down. Equals 4x squared. Now, I think we're going to need a little more space, so let's get some more space to continue solving this problem. All right, perfect. Now, all right. Now, we want to get all of our x's to one side and all of our non-x's to the other. So I'm just going to do 640 equals 4x squared plus 960x plus 480x squared plus, or no, that's a minus 480x squared because I'm subtracting from the left to the right, plus 80x cubed. We can simplify that again. We get 640 equals 400 equals negative 476x squared plus 960x plus 80x cubed. And now the way we're going to solve this, I think for this part, since it does have that x cubed, I know I lied and said we were going to use the quadratic formula. I think we have to use a solver. No teacher I know would require you to know how to solve a thing with the x cubed. So we just have to put that in a solver to figure it out. So putting it into my solver. My solver did not want to work. We are going to say, we're going to edit this a little. We're going to change it. I know normally this isn't what they'll give you on tests, so I feel comfortable editing this. We are going to just take away this ADX cubed and forget it didn't exist. We get the gist of how to get to that point, which is one thing your teacher will test you on. And then the second is solving the quadratic formula. So that's what I want us to focus on. And then next week, we can look more at the solver method. I just know my teacher was more concerned with me knowing the process of how to do it rather than like plugging it into a math solver. So now we are going to use the quadratic formula. So we have 640, just writing it so we have enough space, equals negative 476x squared plus 960x. For the quadratic formula, we have to get 0 equals something. It has to be 0 on one side for the quadratic formula to work. So we would get 476x squared minus 960x plus 640 equals 0. And then we're ready to put that into the quadratic formula. So if you need to refresh, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song. If you know the song, you know the quadratic formula. It never leaves your brain. I learned the song like, I think 10 years ago, 8 years ago, and it's still in my head to this day. But a is always what's with our x squared, b is always what's with just the x, and c has no x involved. So now we just need to plug those numbers into that quadratic formula. So b, we have negative b, negative 960 is just a positive 960. Then plus or minus b squared, so 960, negative 960 squared minus 4, a is 476, c is 640, all over 2 times a, 2 times 476. Now, let's put that in our calculator and solve that. So I'm going to start with working what's in that square root sign. So 960, negative 960 squared is 921, 600. Then 4 times 476 times 640 is 1,218,560. What have I done? Okay. 960 plus or minus, and then 2 over 476, 2 times 476, so over 952. All right, now let's solve that square root. So for that square root, we're going to get 544.9 over 952. And then let's put that in our calculator. So we should get two answers. We can either say it's 0.67, or if we do the minus version, if we do 960, or if we do the plus version, 5 plus 544.9 divided by 952, we'll get 1.58. So I know I would also have some problems where I had to decide what would be more realistic. And so the way that we figure out what's more realistic is we go back to our ICE table and we look at what we start with, and we want to pick the answer most similar to what we start with. So if we know we either got 0.67 or 1.58, we go back to our ICE table and we started with 4 and 2. So I would pick what my teacher would want me to pick is the 1.58. Since it's most similar to what we started with, it's most likely that x is 1.58. And then what our question is asking is what's the concentration of N2? So we're not done yet. We have x equals 1.58. But now we need to figure out what N2 is. And so to find what N2 is at equilibrium, we plug in that X right there. So 4 minus 2 times 1.58. Let's put it in our calculators. Got about 30 seconds to put that in your calculator. While we're waiting, I see a question from John on TikTok. How do you go from grams to grams? I'm not 100% sure what you're asking, but maybe if you ask it a different way, I would be happy to answer. So I encourage you, type in those questions. I'd love to answer them for you and help y'all with your learning. Our final answer for our N2 concentration, if you put that in the calculator and you're following along, you should have gotten 0.84 molars. So if you got that, great job, guys. All right, that was kind of a long question. We kind of cut a little bit of some corners there, but I think if you don't get the gist of how we do the problem, type that in the chat because I'm more concerned that we know how to solve the problem, like the steps and not necessarily the math behind it. And again, the reason we skipped over that is I know no chemistry teacher that's going to expect you to solve an equation with an x cubed in it in your head unless you have like a graphing calculator. All right, so we are about 2/3 of the way through our live stream. If you're just now joining in, it is so great to have you. I'm Allison. I am your host for the Stoichiometry Chegg live office hours. There's a QR code in the top left with all of our office hours for all week and some resources provided by Chegg to help you learn. So I encourage you to check that QR code out. And I also encourage you to ask as many questions as you can in these last 20 minutes. I would love to answer your questions. That's what I'm here for. So anything you were confused about in class, any homework problems you have, type those in the chat and I'd be more than happy to answer them for you. All right. Now we are moving on to a limiting reactant problem. This is another thing we've kind of been struggling on the past few weeks, so I wanted to touch on it a little. And also, if there's anything I haven't touched on that you kind of want more information on, you can type that in the chat. And if we have time left, we'll go over that. If not, I'll add it into my prepared problems for next week so you can be assured that I'm going to solve your problem or have examples ready. And so this was one of those last week was we wanted more information on limiting reactants. So let's figure out about limiting reactants. So a limiting reactant is is the reactant that allows us to not make more product. In most chemical reactions, we have 2 or more reactants, and one of those reactants is going to allow us to not make more product. And then our excess reactant is we have enough of that reactant to make as much product as we want. So we want to find what's the limiting reactant if I start with the same amount of each reactant. So does anyone have any ideas on what the first step of this problem would be? Hint, it's not going to be any math. Got about 10 seconds. Tell me, what's the first step of this problem? What should I do first? All right. If you said balance the chemical equation, you're absolutely correct. We need to balance that. And we need to figure out what the products are. The reason I picked this is because I don't really think we've had practice going from reactants to products and figuring out what products are. This is a double replacement reaction. Goodness, can't speak tonight. So basically that means the cation of one is going to go with the anion of the other, and the cation of the anion of the other is going to go with the cation of the one. So we're going to get AgCl, and the reason there's like no 2 subscripts or anything is this Ag has a 1 plus, the Cl has a 1 minus, so they cancel out. And then we have Mg and NO3. This one's going to be weird because this Mg has a 2 plus and this NO3 is a 1 minus. So when we cross them, the NO3 is going to have a 2 subscript. If that doesn't make sense, let me know now. You can send a thumbs down or something so that I can better explain that for you. But I do know that a lot of chemistry teachers are going to require you to know how to find those balanced equations. So now we need to balance it. Make sure the elements on the left equal the elements on the right. We have 1 Ag, 1 Ag. We have 1 NO3, but we have 2 NO3s over here, so we need to make that a 2. We have 1 Mg, 1 Mg, 2 Cls, only 1, but we do have that 2 Ag there, so we can make a 2 there. Now let's do a final check. My final check is going to be in pink. 2 Ags, check, 2 Ag, check. 2 NO3s, check, 2 NO3s, check. 1 Mg, check, 1 Mg, check. 2 Cls, check, 2 Cls, check. All of my elements on the right and left match, so I am good to go. Now, what I need to do is find the limiting reactant. So to do that, I pick one product to take both of my reactants to. I'm going to pick AgCl just because it's the first one I see. There's no reason. It doesn't matter which product you choose. And then I'm going to pick a number of each reactant to start with. I'm going to say, let's do 10 grams. That's what I'm feeling tonight. So we're going to start with 10 grams of each. And then, so let's see, 10 grams of AgNO3, 10 grams of MgCl2. And then let's kind of map how we're going to get from this gram to the moles of our AgCl. And that's important because whichever creates less moles of AgCl is the limiting reactant. So for grams, I'm going to go to moles of AgNO3 because I can only convert to AgCl if I go to moles first, and I can use those coefficients of the balanced equation to get to my moles of AgCl. And then, so like I just said, we go moles of AgNO3 to moles of AgCl. If you are ever wanting to switch from one product to another, you always have to go to that moles first. You have to use moles. If you want to go from one compound to another, you have to use moles. Get that ingrained in your brain. And then let's do the same for the bottom. Grams of MgCl2 to moles of MgCl2. These problems are nice because if you map one, you can map the other, and it's super easy. And then we have moles of MgCl2 to moles of AgCl. All right. Now what we need to do is find our molar masses. We need a molar mass of AgNO3, of AgCl, and MgCl2. So let's start with AgNO3. So our molar mass of Ag is 107.87. So we'd have 107.87. I'm going to write it another way. So if you didn't really understand how we found molar mass the first time, this might be more visually helpful. Plus 1 in N, so 14.01 from the periodic table, plus 3 O's, so 3 times 16. Then we'll simplify 107.87 plus 14.01 plus 48, and then we'll put that in our calculator. So I put 107.87. Try to beat me to solving this. Type your answer in the chat when you have it. Plus 14.01 plus 48. If you got 169.88, you are correct. Ag, well, we already know it's 107.87 plus Cl is 35.45. You've got 10 seconds. Put this in your calculator. We're just trying to find those molar masses right now. All right, MgCl2 is our last one, and I completely skipped over. If you got 143.32 for AgCl, you're absolutely correct. Okay, you have 30 seconds to find the molar mass of MgCl2. I'm not going to show my work for this one. I just want to see if you guys can solve it or explain to me how to solve it before I do, okay? You've got 30 seconds. All right, about 10 more seconds, guys. 3, 2, 1. If you got 95.21, you are correct. And I'm going to include my units because I would be a bad teacher if I didn't include all my units on these. They should all be grams per mole. All right, now we're ready to go back to our problem and solve. So we have our moles always get these 1 coefficients when we're going from grams to moles. We determined that grams of AgNO3 was 169.88. We determined that grams of MgCl2 was 95.21. For this problem, we actually didn't even need the grams of AgCl, but I was just helping y'all get more practice. Just kidding. That's my bad, but hopefully you better know how to do molar mass now. And then we want to get from moles of AgNO3 to moles of AgCl, moles of MgCl2 to moles of AgCl. So the way we do that is we look at these coefficients in our balanced chemical equation. So for AgNO3 to AgCl, we have a 2 in front of that AgNO3. That's what I found right there. And for AgCl, we also have a 2. I found that right there. So you can kind of follow where I'm getting that from. For AgCl, 2, MgCl2, there's no coefficient, so we assume it's 1. Now, I'm going to give y'all 1 minute to put that in your calculators and figure out what the moles of each of my compounds are, or what the moles of each AgCl, so we can figure out the limiting reactant. Bonus points if you figure out the limiting reactant in this 1 minute. If you get stuck or if you want to check your work, I'm going to go ahead and put the first answer up. Welcome to the live stream. If you're just joining, it is so great to have you. And I encourage you to ask any questions you have with this time that we have. I want to help y'all better understand the content. I also encourage y'all to actively engage in the problems we're solving so that you can learn. But please ask those questions. I'd be more than happy to answer them. We're in the middle of solving this limiting reactant problem if you're a little lost as to where we are. Yes, if you have a problem, type that in the chat and I'd be more than happy to answer it for you. All right, we've got about 20 more seconds on this problem we are on. I'm putting the second answer on now, so you can check your math. All right, so those are both of the answers. And now we need to determine what our limiting reactant is. I'm going to give y'all 10 seconds. Take a vote in the chat. Which is the limiting reactant? Is it AgNO3 or MgCl2? We'll see which side gets it right. So vote in the comments. Say what you think the answer is. You've got 10 seconds. AgNO3 or MgCl2? 3, 2, 1. If you said AgNO3, great job. You are correct. AgNO3 is the limiting reactant. You might be asking, hey, why is AgNO3 the limiting reactant? That is because it creates less product. It creates less moles of product. We can see that in our math calculations. 0.059 is much less than 0.21. So if it creates less product, it's the limiting reactant. And then we also know that MgCl2 is the excess reactant because it can create more product than the limiting reactant allows. All right, we have about 6 minutes left of the live stream. This is your last chance for the week to ask any stoichiometry problems you have. The chemistry live office hour session might be able to help you also. But this is one of your last chances for this live stream to ask questions. So if you have any questions, type those in the chat. I want to help you guys better understand, so I encourage you ask anything that you can think of. Yes, if there's a problem you don't understand, type that in the chat and I will help you. I will solve it. and we'll do the math for it. That way everyone can understand. While we are waiting for any questions, let's solve this last problem I prepared. Convert 0.72 grams of silver to atoms. And I should have been more specific and said atoms of silver. We're not just converting them to atoms of anything. We're converting them to atoms of silver. So for this, if we remember our flow chart that we went over a few weeks back, we had to go from grams to moles to atoms. To get from grams to atoms, you have to go through moles. So what we're going to need is the molar mass of silver. I don't know that one off the top of my head. So let's see. Okay, it's 107.86 grams per mole. All right. And then what we're going to do is we're going to start with our 0.72 grams. We're going to go from grams to moles like we discussed. 1 mole has 107.86 grams. And then any ideas on how we're going to get from grams to atoms? Does anyone have any ideas? I'm going to give y'all 10 seconds. How would we get from grams to atoms? Or what's the number to get from moles to atoms is the better question. And what's the special name for it? Bonus points if you remember this number. All right, 3, 2, 1. We need Avogadro's number, which, if we remember, is 6.02 times 10 to the 23rd. And that can mean, yes, good job, Yo from TikTok. Avogadro's number is absolutely correct. That is how many atoms or molecules are in a mole. That's what that number stands for. It's universal for any element. Silver, gold, carbon, all of them have 6.02 times 10 to the 23rd atoms in a mole. How they found that out, I don't know, but I'm sure it had to do with something that Avogadro did. Now we want to go from moles to atoms. So what we're going to do is we have 1 mole equals 6.02 times 10 to the 23rd atoms. You guys have 1 minute to put that in the chat. What is that answer? Let me know, guys. See if you can beat me in solving this. All right, about 30 more seconds, guys. All right. If you said 0.401 times 10 to the 23rd or 0.0401 times 10 to the 23rd, you are absolutely correct. I'm going to encourage you, though, put that in correct scientific notation. Okay, you got 30 seconds. Put that in the correct scientific notation. 3, 2, 1. It should be 4.01 times 10 to the 21. If you got that correct, you are absolutely doing amazing. I'm so proud of you. Our last question we're going to look at from Frank on YouTube. Determine group and period of the element whose electron configuration has 9 electrons in its dilobular orbitals. Okay, a dilobular orbital is it's a d orbital from what I remember. Now, the tricky thing about this question is I think there could be multiple answers because there's multiple d answers. Great job, Yo from TikTok. You solved that correct. So if we go to the periodic table, what we would do is we'd find where on the periodic table would D have 9 electrons, the d orbital. And the first one that I see is copper. And so I just looked at my d orbital area of the periodic table, went over 9 rows. And so that is row 4 in period 11. That's how I would know to solve this problem. It is a weird question because with that problem from Frank on TikTok, there's multiple answers, so it does make it a little confusing. But we are about at our time for tonight. Hopefully that answered your question, Frank. We will work more on that stuff next week, so I encourage you to join. I'll make sure to put some questions about finding elements based on their orbitals. Thank you for joining this live stream. It's so great to have you. Check out the QR code for more office hours this week. And I hope you come back next Wednesday, same time. And just thank you to Check for all the resources it's providing for learning. It's great to see you. Hope to see you guys again. Bye.